Okay, so let's take a look at this normal distribution example, right? So it says the time t minutes taken to complete a jigsaw puzzle can be modeled by a normal distribution with mean mu and standard deviation 8.6. Okay, it is found that 30% of the times taken to complete the jigsaw puzzle are longer than 36.8. Right? By stating and solving an appropriate equation, show correct to 2 decimal places that mu is equal to 32.29. Okay, so now first of all, we have an unknown here, so we don't know what mu is. So typically, whenever either the mean or the standard deviation is unknown, we know we're going to be using the z-score formula. Okay, so remember the z-score formula is z is equal to the x value minus the mean divided by standard deviation, right? Now let's make a sense of this information real quick. So let me just make a quick sketch. So we have a normal distribution, right? The mean we don't know, right? And standard deviation is 8.6, okay? Now it says it is found that 30% of the times taken to complete the jigsaw puzzle are longer than 36.8, okay? So we have 36.8 and are longer than 36.8. So the 30% that they're talking about has to be this area right here. So they're saying this area right here is 30%. So they're saying this is 30%, 0.3, right? So when you set up the z-score, now I typically always like to use the area to the left of the value, right? So if this is 0.3, that means all of this right here, right, must be 0.7. So when I set up the z-score, I'm going to have 0.7 is equal to the x value, which is 36.8, minus the mean, which we don't know, divided by the standard deviation, which we have is 8.6. Okay? Now remember, whenever you're using the z-score formula, we have to inverse norm this value, right? So we're going to inverse norm this value on the calculator. So let me inverse norm that. So probability distribution, inverse normal. So our area is 0.7. All right. Now remember, we're going to leave this 0 and 1. All right. Anytime you're using the z-score formula, leave this 0 and 1. So we have OK. So we get 0.524405. All right. So we get 0.52440, 0.5244. Okay. So this is going to be 0.5244 is equal to 36.8 minus mu over 8.6. So if we solve for the mean, we're going to get 8.6 times 0.5244, right? That's going to equal 36.8 minus mu, right? So if we solve for the mean, we're going to get the mean is equal to 36.8 minus 8.6 times 0.5244. So if you calculate this, we should get the show that they want, 32.29, right? So let's calculate this real quick. So 36.8 minus, we have 8.6 times 0.5244. So minus 8.6, so I'll put it in parentheses, 8.6, right, times 0.5244. Click enter, and we get 32.29, right? So then we end up with mu, the mean is equal to 32.29, which is what we were trying to show. Okay? Okay, so let's take a look at part B right here. Okay? So part B says, first of all, use, all right, the mean 32.29 in the remainder of the question. So the reason why they tell you this is if you couldn't get the show part in part A, right, you can still use it to do the rest of the problem. Okay. All right. So we're trying to find the 86th percentile time to complete the jigsaw puzzle, right? So basically, the situation is we have a normal distribution. We know the mean now is 32.29, and we want to know, well, the 86th percentile. So let's say 86th percentile somewhere like right here. We want to know what time, right? And then this area right here, they're saying represents 86%, right? So 0.86 represents all this area right here. Okay, so to calculate this, well, we actually have everything we need, right? Because we know both the standard deviation and the mean now. So let's just go to calculate, right? So we're going to I'll bring up a new one. Calculator, we'll go to inverse. All right, inverse normal, because we know the area, which is the 86th percentile, 0.86. Now, when you know both of these, you can input them, right? Only when you know both of them. If you don't know one of these, leave it 0 and 1. So since we know both, we can just input it. So we have 32.29. This is, let me see, 8.6, standard deviation, 8.6. Click OK, and we get 41.6. So we know this x value here is 41.6, right? So 41.6 minutes, right? That would put you at the 86th percentile, okay? All right, so let's take a look at part C here. So it says find the probability that a randomly chosen person would take more than 30 minutes to complete the jigsaw puzzle. Okay, so we're trying to find the probability, right, that the time is going to be greater than 30. Okay, well, we have all the information we need, so we're just going to do a normal, all right, normal CDF on the calculator. All right, so normal CDF, let's calculate that. So norm CDF, probability distribution, normal CDF, because it's an inequality. Now we want to know when it's greater than 30. So our lower bound is going to be 30, and our upper bound, remember, we're just going to put a bunch of 9s. Okay, and then our mean was 32.29, and our standard deviation was 8.6. So just input all this, click OK. Right, so we get 0.605. Okay, so make sure you write down what you put in the calculator. Okay, so this was 30, comma, and then a bunch of 9s, right? And then we have 32.29, and then 8.6, and then our answer was 0.605, right? Okay, so let's take a look at the next part here. So 4D, 6 randomly chosen people complete the jigsaw puzzle. Find the probability that at least 5 of them will take more than 30 minutes to complete the jigsaw puzzle. So when you read this question, right, you have to recognize right away that based on the question, this is turned into a binomial, right, distribution type question, right, where let's say capital X is going to be binomially distributed. So there's 6 randomly chosen people now, right? And then the probability that they take more than 30 minutes, right? Now remember, we actually calculated that previously, right? In 4C, we calculated that what's the probability that someone takes more than 30 minutes. That was 0.605. So that probability is 0.605. Okay? So in this situation here, capital X represents the probability that someone's going to take more than 30 minutes. Okay, so you have to recognize that this question here, right, this problem started as a normal distribution question, but when they ask this question right here in 4D, you're going to use the information that you've already calculated, right? And then this question becomes a binomial distribution question based on what they ask, right? Because it meets those 4 requirements for a binomial distribution, right? So we're going to calculate, well, what's the probability, right? Find the probability that at least 5, right? So capital X is going to be greater than or equal to 5. Okay, and then let's calculate this. So binomial CDF. So we have probability distribution, and this is a binomial CDF now because it's an inequality. Our number of trials, right? I believe there was 6 people. So we have number of trials is 6. Probability of success was 0.605, right? This is the probability that someone completes it in 30, right? It takes more than 30 minutes, right, to complete the puzzle. And then our lower bound, so 5 or more. So basically, our lower bound has to be 5, and the greatest is going to be 6 because there's only 6 people. Okay, and then we get our answer 0.241, right? 0.241, and you want to make sure you write all this down so that the reader knows what you put in the calculator, right? So we have binomial, all right, CDF parentheses, and then this was 6 comma 0.605 comma 5 comma 6, right? And then our answer we got was 0.241. Okay. All right, so let's take a look at question 4E here. So having spent 25 minutes attempting the jigsaw puzzle, right, a randomly chosen person had not yet completed the puzzle. Find the probability that this person will take more than 30 minutes to complete the jigsaw puzzle. So this question is kind of tricky because when you read this, you have to recognize that based on what they say, this is now a conditional probability question, because the condition is having spent 25 minutes attempting the jigsaw puzzle, right? So that means the person has to have spent, right, at least 25 minutes to complete it. So this is our condition. So this makes this now a conditional probability type question. So you have to recognize that, okay? So we're trying to find the probability that this person will take more than 30 minutes, all right? So we're trying to find the probability, right, that this person is going to take more than 30 minutes, okay? So the time is going to be greater than 30 minutes, right? Given, right, that the time is going to be greater than 25, greater than or equal to 25. So using the conditional probability equation, we have the probability that t is greater than 30, right, intersect with t greater than or equal to 25, divided by the probability, right, that t is greater than or equal to 25. Okay, now you have to think about the top here. So what's the intersection of the time greater than 30, right, and the time greater than or equal to 25? So think of like a number line, right? If you have like a number line, let's say here's 25, right? So greater than 25 is like this. Now 30 is like this. So the intersection is where they overlap. They overlap here, right? So basically the numerator here is just really going to just be, so the intersection of this is really just when the time is greater than 30, right? Divided by the probability of the time greater than or equal to 25. Okay? So the probability of the time greater than 30, we've actually already calculated that previously. Remember, we calculated this previously, I believe, in part C, right? In part C, and that was 0.605. Okay? So we actually already know this, right, from part C, which was 0.605. Now the probability that time is greater than or equal to 25, we don't have this yet, so we need to calculate, so we don't know what this is, so we need to calculate this, right, using a normal CDF. So we're going to do norm CDF for this. So let's calculate this. So we've got a norm CDF, normal CDF. All right, so we want to calculate greater than or equal to 25. So our lower bound is 25. We can put a bunch of 9s. We know this value is 32.29, and the standard deviation was 8.6 that we've been using for this whole question. Okay. And then we get 0.8016. So you want to kind of keep a lot of decimals. 0.80169, right? So this is 0.80169, and then we just divide this right here, right? So then we're going to end up with 0.755 as our final answer. Okay?